Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nurhidayah, NIM 901051. I want to explain about plastic modification. The use of plastic in the era of technological advancement is increasingly widespread. One type of plastic that is widely used in everyday life is a packing bag of the LLDPE type. As a plastic backing, LLDPE is generally used only once and then discarded. LLDPE is inert, so it is very difficult to be broken down by soil microbes. As a result, there is an accumulation of plastic waste which can pollute the environment. Until now, plastic bag waste is a serious environmental problem, not only in the developing countries, but also in developing countries. Various attempts have been made to create biodegradable plastics. For example, by mixing LLDPE with starch, it turned out that this business could not satisfy consumers because the biodegradation process took too long and only the starch and the end of the polymer were biodegradable. The molecular structure of a polymer is a determining factor for a polymer to be biodegradable or not. From the available data, it shows that synthetic polymer, which in the main chain contain hydrolyzed and oxidized functional groups that are relatively more easily biodegradable. LLDPE molecules consist of carbon and hydrogen atoms and do not contain functional groups that can be further hydrolyzed or oxidized. In this regard, it is necessary to make modification to the LLDPE structure or by adding additives that can invite microorganisms to decompose plastic waste, and if this is done successfully, environmental pollution due to LLDPE can be dissolved. Research to modify the structure of LLDPE by means of oxidation, photooxidation, copolymerization, and blending has been carried out, and the result has been found that there are functional groups that can be further oxidized and hydrolyzed. For example, ketone ester. However, the result of the studies still show a decrease in tensile and elongation test in the oxidation results. However, research to modify use LLDPE has not been really carried out. In this research, a modification of LLDPE waste will be carried out through a blending process with natural materials to make it a more degradable plastic packing, so it is more environmentally friendly. It is estimated that this can be done considering that LLDPE is a polymer material that is thermoplastic in nature so that it can easily be reconstituted after being melted. Modifications are made by adding natural ingredients from the type of cellulose. Cellulose is found in several parts of the plant, including plantation with the functional group that is mostly present in cellulose is a hydroxyl group, in addition to the other group. If this material is mixed with LLDPE, it is likely that the cluster will be easily is oxidized to form ketones, and if it continues will be able to produce carboxyl groups in the form of carboxyl acids. Based on Moin's research, this group is the favorite group or a food for microorganisms. So that eventually the long polymer chains from plastic bag waste can be degraded. Although the main objective of the research is to reduce plastic waste made from poly, poly, polyethylene, there are other problems arising from modification. Several research results indicate that the modified polymer from natural fibers has long mechanical properties, especially in the properties of tensile strength. However, when studied further, the fibers used as an additive has a large enough particle size in these studies, so the crystalline properties are also long. Crystalline properties will affect the density and regularity of the positions of atoms in a material. Materials that are crystalline generally have better mechanical properties. Therefore, before being used as an additive, BKS cellulose fibers will be reduced in particle size, nano size, so that the small particle can fill all parts of the plastic material, and the effect of mechanical properties can be maintained. Nano-sized additives from cellulose of mechanical properties can be maintained. Nano-sized additives from cellulose are often called nanocellulose. Nanocellulose is a natural nano-sized polymer that is obtained after going through various processes, generally derived from several parts of the plant. In oil farm plants, for example, on wood stalks, midribs, and empty bounds, the older the plant, the higher the cellulose content. In addition, this material is also widely available in nature or is renewable. It is hoped that improvements will be found in the mechanical properties of recycled plastic if it has been combined with cellulose as the filling material, especially in the tensile strength of the material resulting from the blending process of the two materials. And it is also hoped that after adding natural materials, the potential for degradation in the recycled waste will become higher. Okay, that's all for me. Thank you for your watching. Assalamualaikum warahmatullahi wabarakatuh.